After that excellent talk about decision making, I'm now going to talk a completely different thing altogether. We're now going to talk about continuous integration, continuous deployment in GitHub Actions. Because I'm interested in how we test and release software. Should be fairly easy. There's a number of steps we have to do. We have to do a number of processes in order to accept a code change into our main or master branch. We have to check out the code. We're going to have to install some dependencies. We have to compile it, or we're creating containers, something like that. We've got to run code style checks, we're going to run tests. We're going to get failures because there's invariably failures. We're going to have to tell the developer what went wrong, and we're going to have to let everyone else know as well. Set of steps that needs to be done in order to accept code into our project. Similarly, for releasing a new version of our project, set of steps that needs to be done. That's fairly similar. Checking out source code, we're compiling it, creating that container. We're uploading that container to a registry. Maybe we're deploying the container orchestration system to actually get the release happening. Publishing it so that everyone knows it's happened. And we're going to obviously tell Slack that we've succeeded in doing our deploy. Set steps, a list. Never ever get it right. There's always a step that gets missed, gets done out of order, gets forgotten, gets skipped. Because humans are really, really, really bad at repetitive tasks. We're just not very good at it because we get bored. We know how to do it. We've done it a million times. It's very difficult to do the same set of steps every time, which is why we invented computers. So they are really good at doing the same wrong thing every time. So have tests, making sure our software works. CI, sure that we run them. And then CD, sure that we release reliably. That's what I'm interested in. Our source code repository is the center of everything we do. Therefore, that's where we should be concentrating the automation. GitHub, we're going to use GitHub Actions. If you're in Bitbucket, you're going to use their pipelines. If you're in GitLab, you're going to use their system. This talk is all about GitHub, but practically the same sort of things can happen in all the different pipelines. Really sorry. From now on, there's an awful lot of YAML. There is a lot of YAML from now on. Essentially, the rest of this talk is I'm going to show you and talk through the way that I use GitHub Actions and the various workflows I use in projects I do, both open source and with my clients, to give you an idea of the sort of things that you can do with this scripting system that maybe you've not done before. So I'm taking a guess that most of you've got some sort of CI going already. So you're going to see something like this. You've probably seen all this before. We have a YAML file. It lives in .github/workflows, and it's got a name, and then it's got an on. The on is when will you run this particular workflow. There are a lot of events in GitHub that you can use to trigger that workflow. Loads of them. There are 33 repo events. Where did my slides go? They're the green ones. When something happens within your GitHub project, you can trigger the GitHub workflow to run. Then you've got the orange one, which is a webhook. So you can trigger any GitHub workflow directly via sending an API call into GitHub. The magenta one is your schedule. You can do it on a time. And the blue one is manual. You can literally press a button in the GitHub website and run your workflow. Loads of different ways that we can run our workflows. Pick the ones that are most useful to you, depending on what you're doing. Then you've got your list of things you want to get done. These are your jobs, your steps within your jobs. So this one has a name, it's a QHX. Where's it going to run? It's going to run on Ubuntu. You can also use Windows or Mac or something like that. And then you've got your steps. What do you want to get done? This is the world's simplest workflow. It has just 2 bash commands. Say hello and all done. And when you run it, you get this output. Nice and easy. A little checkbox, say it's successful. And if it fails, you get a red one. So it's really easy to see what went wrong. What are the sort of things we want to do? Firstly, we're going to do some quality checks. This is the bit you already probably do. So the PHP checks, all the stuff at the top looks the same. The interesting bits are in the steps. You go check out your source code. One thing about GitHub Actions is your source code is not available unless you check it out. So don't forget to check out your source code. Create an env file. Probably got some configuration that your app requires. So I have a .env.ci file. I copy it over to create .env, and then I can do some work. Need PHP. Contrary to popular belief, PHP isn't actually installed on every single computer in the world. So you have to install it yourself. There's a useful project out there which is already written for you, an action called setup PHP. And then we pass in the parameters that we need to use with it. So the action is a third-party action. The with section enables us to pass in the configuration for the action. I want pcarf, I want PHP 8.3.4, and I want Composer and CS2 to PR. Because then I can run Composer, which we're already doing because we need our dependencies. I can probably run npm because invariably there's some JavaScript stuff now. And then we get on to PHP CS for our code style. We get on to static analysis using PHP stan. Other static analyzers are available. And we run our unit tests. Right, that lot you should all be reasonably familiar with if you have ever done GitHub Actions before, because that is really, really common. What other stuff can you do? You can check the licenses of your PHP dependencies. Now, if you're in the open source world, you probably don't care about this so much because everything is open source and it's all fine. I work for a number of commercial clients that care very much that their software remains closed source. And to have closed source software, you don't really want to bring in a dependency that will accidentally create an open sourceness of it, like copyleft. How you test that in court doesn't actually matter if the company's lawyer says you may not have code with LGPL or GPL dependencies. So stick it in your CI. Right, my script is called check licenses. It runs Composer because Composer has got a really, really helpful function that will list all the licenses of all your dependencies. Run it, check it worked. Can you cache your routes? In Laravel, you can cache your routes using artisan root cache. Sometimes this will fail. On one company project, we discovered this could fail in production. Not the best time to discover this. We put it into our CI system, and we never had that mistake again. I literally cannot remember what the mistake was, but someone had committed the wrong thing. As a result, we couldn't cache the routes. We put it into our CI, problem disappeared. Tailwind build. I'm not a front-end developer. You might have heard at the beginning, I'm an API person. My idea of the perfect website renders to JSON. There's this thing called HTML, there's this thing called JavaScript, and there's this thing called CSS. I have literally no idea how any of that works. However, the people that do know how that stuff works use something called Tailwind. And my understanding of Tailwind is that you write in some sort of language, press a button and it creates CSS. I could be wrong about this, but it's something along those lines. Those artifacts on one of our projects were committed into the repo for reasons. Sometimes pull requests would happen where the developer had forgotten to commit the output of Tailwind. And guess what? Nobody noticed until we got to production. Isn't it amazing how you only ever find stuff by the time it gets to production? Guess what we did? We created the CI thing so that we would never forget it again. Specifically in this case, tailwind build, and tailwind build will return, tailwind build will generate the CSS files. So if they are not in Git already, what will happen is you'll end up with modified Git files. So then I can use Git status to discover if there are any modified files in the Git, and then use the bash test system to return an error code which will then fail my check. Docker. We're all using Docker nowadays. Well, maybe not all of us, but a good proportion of us are using Docker. If you are using Docker in development and you are using Docker in production, use Docker in CI too. GitHub Actions makes this trivial because it's basically just a Linux machine. So we can do Docker compose pull, we can cache our layers so that we don't have to keep rebuilding them because it takes forever. And we can run Docker compose up, and we now have our Docker system running. Everything looks the same. I can now run my functional tests and my integration tests. Things that hit the database can now be run very simply in CI. And I'm doing it exactly the same as the way I do it in dev. It's exactly identical. However, MySQL is not the fastest application in the world for startup. And GitHub Actions is really quick. So you end up, if you're not careful, having to wait for MySQL to turn up. And there's a lovely little script called wait for it, which will do that for you. I'm looking here for port 3306 on the DB container, but that also works if you've got other types of systems. So if you've got waiting for a Redis or something like that, that will also work. Run your migrations, and then you can actually exercise your tests. Another project I run is called RST to PDF. Now this is a project where we write RST files, which is like Markdown, and it generates PDFs, the clues in the name. The test suite for that is output PDF files that we check against reference PDF files. So if the PDFs are different, then we know we failed the test. We also use a similar system for doing, what's the system called? Playwright. If you've got a Playwright set of Playwright tests, if you're doing your tests at the acceptance level, you do the same thing. When a failure of a Playwright test happens, it will generate a picture of the failed web page. So now you've got an image that you would like to give to the developer to show what went wrong, or in my case, a PDF. GitHub Actions comes with a set of file system where you can upload your assets. There's an action called upload artifacts, and we can use it only if there is a failure. So this particular step only runs if failure happened. And if it does fail, then we will create an area in the storage system called failed tests, and we will upload everything in the output folder. And now I can send that to my dev to get the problem fixed. You don't get infinite space with GitHub Actions. They will start charging you lots of money. You probably don't care about any test that you ran 2 weeks ago, because you're probably not going to look at that test again because you've got further tests in the future. So stick your attention days on, and GitHub will remove these files automatically for you, so you never go out of your storage limit. All that stuff that I run in CI, I run locally. Help your developers to help themselves. In an ideal world, a developer raising a PR should never be surprised that the CI failed. That should have been a shock. So make it easy for your developers to run it locally. This is one of the reasons why Docker is so good at this sort of stuff, because you can Dockerize it locally. You can run the same Docker stuff up on in CI in GitHub Actions, and it's all quite similar. So that's the CI side. Let's talk about CD. It's all the same sort of stuff, but now we're doing slightly different things. We're going to need to tag our source code. We're going to have to release it. Tagging has to happen at an event. The way I normally do it is when we close the milestone. So we create a milestone in GitHub that represents our next release. Then when that milestone is closed, to do a checkout. I need to do a full checkout rather than a shallow checkout because I'm going to do a tagging. Then I go create my tag. Very helpful action called create tag, which will do that for me. And now I've got my tag. Then I go create my GitHub release. The GitHub releases are a GitHub where you can have all your formal releases. It's quite helpful because it makes it easy for things to work. What we do is we use something called GitHub script. GitHub script enables you to run JavaScript directly within your GitHub Actions. So you can, anything that you write in JavaScript, you can just do within the GitHub step. Rather helpfully, GitHub script is automatically authenticated to your GitHub repo and has a GitHub SDK installed. So it's fairly easy just to use the github.rest.repos create release, and we now have release on the GitHub with the release notes automatically generated. And we create a new milestone the same way, because if I close this milestone, I need a new milestone for the new work that's happening, unless of course you've finished your project completely. But most of us haven't. This requires two different actions. Next semver will return us the next version number. So I've just closed version 1.1.1. It will generate 1.1.2 for me. And then create milestone will do the work for me. So now I've automatically created the next milestone. I haven't forgotten to do it. The system has done it for me. To get data from one step to another step, we use ID. So set an ID on the first step, and then on the second step, I can reference it using steps.thatID. So that's quite an easy way to transfer data from one step to another, which you can then generate some more logic. This particular action is a third-party action, and therefore it doesn't have full access to my repo. Security matters. GitHub has secrets. You have to manually pass them in. A GitHub action can't go delving in your secrets and pull out the ones it thinks it needs, because you can imagine the problems related to that. So we pass in the GitHub token, and it's all good. Compile and upload binaries. Another project I do is a Go project where we need to upload binaries. So we now do it on a published release. So we've published our release, but this time we build the executables, and then we upload them. Same sort of process. The key thing here is, what am I doing that I have to keep doing over and over again? How do I automate that so I never have to remember to do it? This one is quite cool because it adds it automatically to your GitHub release page for you. So the artifacts are where your users expect to find them. That's great if you're writing a program. What happens if you're doing an actual website? Are you doing Docker? You've got to push your containers to your repository. So ECR if you're on AWS maybe, or Docker Hub or wherever. Again, it's on publish. Again, you're doing the same sort of steps. This time we're doing the Docker build, but we're going to tag it. So we're going to tag it with the ref name, which is the tag name, or the release name, which is the same for me. So once we've done that, we can push it to ECR. Again, secrets matter, so you have to tell the action your AWS key ID and secret, and it will not get them for you. And then where you put it. Don't put it in US East 1, but I assume you already know that. US East 1 is unreliable at best. Give it a local, the local image is what it was created on disk, and then the image is what you're going to tag them into ECR. Generally, you're going to do the version number and you're going to do latest, and then your system will pick up from there. That's essentially the sort of stuff I do all the time. And you should be able to see how it works. There's a few other stuff that GitHub does, but we're not going to talk much about those. Banging on about secrets. I've seen secrets hard-coded in those workflow files. Do not ever do that. GitHub provided the secret system for a reason. Use it. Conditionals are fantastic for saving time. There's no point in running your PHP unit tests if the only changes were related to CSS. You can use the if statement to stop that. I'm a huge fan of Bash. I like writing in Bash. I find Bash is a great common denominator, quite easy to write shell scripts in. If you're not a fan of Bash, you can use Python. Just set the shell to Python, and now you can use Python instead of Bash for all your GitHub Actions. The GitHub CLI, if you're using that, GH. If you're not using GitHub CLI, start using it. It's really, really good for use on your local machine for managing GitHub. If you're into the terminal at least. It's pre-installed onto the Linux VM that's running your GitHub workflows. So therefore, you can use it directly. If you're building a library, so you're doing open source stuff, probably. So I work with Slim Framework, so when we release Slim, we actually want to test it on more than one version of PHP. The way to do that in GitHub is through matrices. I've never needed to use it for my client work, so I've not bothered showing you an example. But if you're doing open source stuff, matrices are a really good way for testing the same set of steps across different versions of PHP or different versions of MySQL or whatever you're doing. It's an awful lot of pre-built actions. You don't have to write all the actions yourself. I showed a number in so far. They're all available at GitHub/Marketplace, which makes it really easy to pick up stuff. You can do some amazingly complicated stuff. Laminas automatic releases is arguably one of the more complicated workflows I've had to deal with, but it is magic. The Laminas framework people spent an awful long time writing a set of workflows that automated every step they needed. So one of the things about running a framework is you've got multiple versions in play at any given point in time. So you've got version 3.8, you might have version 3.9, and you might have version 4, for instance. If you fix a bug on 3.8, you probably need to forward port it to 3.9 and possibly forward port it to 4.0. Laminas automatic releases will automatically generate the PRs you need to forward port changes across versions. It's an amazingly helpful workflow. Highly recommend it if you're doing a lot of open source library work. So that's it. As I said, I've been trying to teach you something about the sort of things that I do with GitHub Actions and the way I use it. You're probably doing something with GitHub already, but you're probably not doing all of the different things that it's capable of. Uploading artifacts is super helpful. Being able to do conditionals is wonderful. If you come across an error that you could have fixed had you known about it earlier, stick it into your CI system. Then you'll never need to think about it again. If it's done in CI, make sure your devs can do it locally. I prefer make for that, and I have a target called make check. But it doesn't really matter. Make sure you have a way that your devs can test things. And finally, a deployment pipeline is an automatic manifestation of your process for getting software from the version control system to the hands of your users. That's all it is. If your process sucks, CI and CD will not help. You will need a good process. Have a workflow written down first, use it, and then automate it. Thank you.
Thank you. Thank you, Rob. Any questions for Rob? No. One question. One question here. I can give him. I give him.
Wow. Can you hear me?
I can.
Yeah. Thank you, Rob. Really interesting talk. I already have some ideas how to change my pipelines that I have on GitHub.
Good.
And the question is, what's your recommendation for the actions versioning? I know that people stick to the @v2, some people stick to the commit, and what your recommendation would be?
This is for when you're using a third-party action and there's a version number on the end. One of the problems with the marketplace is that all those actions are written by developers, and developers are remarkably inconsistent. They're also not very good at semver. So I recommend being as tight as you reasonably can to the version number when you pull in a third-party action, because you are less likely to have it break on you suddenly when they release a new version that does a BC break when it shouldn't have done. But it's software like everything else. So now you've got dependencies in your GitHub Actions. So you need to upgrade them and keep track of them. So in the same way that you are upgrading your PHP, you are upgrading your PHP once a year? Yes? Yes? Upgrade your PHP. Upgrade your dependencies in your composer. That also should be part of your processes. Updating the dependencies in your workflows should also be part of your workflow for your project. So I do it on roughly a 6-monthly basis. That's roughly the time that I go, let's check that all our free versions are still current. That's the best I've got.
Other questions? No. Oh, what? A couple of questions. Last minute questions.
Were you clued in? And this is one question.
So you show many of these things with GitHub Actions. How different is GitLab Actions?
How different is GitLab Actions? I don't know GitLab Actions very well at all, though I found it more complicated to use.
But it's nowhere close to...
It's mostly the same. You have steps that you put your stuff in. It all works reasonably same. I was struggling with running multiple containers where I wanted to get the same source code into both containers. That seems more complicated in GitLab than it did with GitHub. Because in GitHub, I can just fire up Docker Compose within within GitHub. And once I've got Docker Compose running, it's quite easy to mount whatever code I need into whichever container. That seemed harder in GitLab. But I've not actually done much work on that, I'm afraid.
Another one here.
In the beginning of your talk, you mentioned the fact that developers don't like to do repetitive tasks.
Mm-hmm.
And I agree with you. We're very bad at it. So is there a way to automate the process of upgrading your PHP, upgrading your dependencies, such that you can, when a new version of PHP is released, it's automatically like PHP latest? Or how would you go about that you don't have to manually think about the process?
I do this a lot more manually than I should. But I do use a checklist. I'm a big fan of checklists. Upgrading your PHP is more than just upgrading the bit that's inside your Docker container, because there's tests to be run, and then there's dealing with the failures that happened and working out whether something's screwed up or whether you've actually got to change your source code and stuff like that. So it's a project in its own right. The trouble is it's a maintenance project, which means it's really hard to get people to pay for it in terms of time, if nothing else. And you're working in a team, it doesn't really, you've still got to upgrade your PHP, but your manager doesn't give you the time because there's no new feature that they can sell to marketing. It's a problem keeping PHP up to date as a result of all your other dependencies. It's really hard to automate it. Rector is one of the better tools for doing this in terms of actually making the code changes, and that's been mentioned already. PHP code compatibility checker, I think it is called, is remarkably good at giving you a heads up when things change, but it's a project. I think it's a project. I think you should do it. Minor updates, they should be automatic within your composer though. You should be able to just do a composer update fairly safely, because most people follow semver. But doing a major version upgrade or doing a PHP upgrade, because PHP is not particularly semver, does require a bit more effort. Did that help?
Okay. Any other questions? No. Okay. So thank you, Rob Allen.